Hello everybody, welcome to Knox Makers, welcome to Show and Share. We do this every Tuesday, except last week, which was our meeting. But we're back here again, showing off, and you've all had an extra week to make projects, so we have 7 people on the list tonight, which is great. We start our Show and Shares with looking at other people's projects, looking at what they're working on, what they finished, what they've totally messed up. We like to hear it all. So first we have Isaac, who has a mutant multi-tool.
Hello friends, this is my mutant multi-tool. I can't take credit for this. I didn't design this, nor did I manufacture it. I just put it together, but I thought it was pretty neat, so I wanted to show it to you. This is a Leatherman free P2, and maybe some of y'all can relate. Over the years, I've tried carrying a multi-tool multiple times, but it's always frustrating to me. I feel like they never have like a very good set of tools. Like they always prioritize the count of theoretical tools over actual utility. But recently, I realized that now that we have access to 3D printing in metal, we don't have to use the default tools anymore. Obviously, that's not on the desktop quite yet, but services like Shapeways allow you to supply files, and then they will print things in metal for you. And so that's what I've done with this one. The primary blade on this tool I have removed and replaced with this. So this part of it here is 3D printed in stainless steel, and it is a scalpel holder, and it is terrifying and beautiful. I also swapped out the secondary tool on here, which used to be a pair of fold-out scissors, which I thought was completely worthless. What I have now is a T-slot holder, and so you can put like a jigsaw blade in here if you want. This is actually a Leatherman made tool for a different multi-tool, and this is what they call the wood saw, but I like it for breaking down cardboard boxes brutally. And then I also swapped out a couple of other tools for this, which is my favorite bit. And this is a bit driver. And I'm really impressed with the design of this part. The bit driver here uses not the silly flattened Leatherman bits, but real 4mm bits. And you know, a lot of manufacturers make those. You can get them in town, you can get them cheap. You can also get really nice ones. This is a Weehaw. And so this has got neodymium magnets in here. And so it's got magnetic tool retention. And if you pull it out there, you can put it in the side. So now you can have quite a bit of leverage if you want. And if you take it out entirely, it's got a bottle opener. So this to me is a substantially improved multi-tool. And so far I'm enjoying it very well. And I was impressed with the Shapeways service. The metal comes almost perfect. It had just a little bit of powder still to be cleaned up. And of course I had to tap the holes for the screws, but otherwise it was good to go. So I'm gonna hand this around so y'all can check it out, but I'm gonna put a piece of tape over the terrifying scalpel. Please don't pull that out. Please don't hurt yourself.
Thank you. There were other options for that as well, right? They had like different tools that you could send to Shapeways.
Yeah.
Neat. Second up, we have Ben, who is going to show a printer enclosure.
Hi, so I wanted to share how I built a temporary printer enclosure, 3D printer enclosure, because it was a process combining few areas in Knox Makers. So I have only pictures. Oh, NFC. Okay, zoom in.
It's underneath it.
Oh, okay. All right, so I'll skip the design part, but I started by cutting panels on a laser. These were made of hardboard. I also made acrylic panes of glass for a window and enclosure. And as the base, I used a cabinet that I had around. I used it for a 3D printer. It's not very sturdy, not very stable, but does the job for now. So I decided to attach it. I started attaching the separate panels, which was nice to see that everything actually fits, that our laser cuts precisely. And then comes in the woodworking part. It's not much of woodworking, but I was able to cut strips of plywood and found actually some free pieces of OSB board to fill in the gaps on bottom. And the frame will make sure that this hardboard isn't all too wobbly. So basically, after attaching everything with mostly finishing nails and staples, I ended up with the frame of the enclosure. Something of this sort. And it has lots of holes, which I will explain later. And I also 3D printed a stand for the arm of the 3D printer. The black metal part, that's what the printer was supplied originally. That was attached to the printer itself on top. But now there's no room on top. So I basically 3D printed a stand for that, and therefore I can keep printing. And the printer will get better soon. But basically that's the setup where the filament goes through the top into the enclosure. And after that, I needed to have a door for a front door for the enclosure. Therefore, I found some designs on Thingiverse. Decided they're a good base, so I basically recreated those pieces in Fusion 360, resized them, and printed 3 toggle latches. You know, familiar latches. They are similar to what you have on toolboxes and such sort of things. I also have I also printed hinges for the bottom, and they were surprisingly nice and smooth. They just popped up out like that from the after printing. No braking required. And after that, I basically attached the hinges. Here's the panel on bottom is the front panel that is open up. And here are the latches. Ooh. And as closed, it looks like there's something dangerous inside. So it seals nicely. I will probably add some wooden strips inside to make it a little bit sturdier, and maybe some weather stripping. But it's a temporary enclosure until I build actually a piece of furniture for the 3D printer itself. And on the left, I made a series of cutouts for fans. These will be inlet fans because the 3D printer will heat the chamber up, and for some materials I need to make sure that it won't be too hot in there. And there are 4 inlets because I'm not sure which ones I will use yet, so I can just plug them later. And on the right we have outlet ones. We have also a hole for future cables that will be, all the electronics will be moved out of the enclosure, and lots of mounting holes for future use. And the last is the top, where I plugged all the holes, and they are mostly for filament. And probably in the future, when upgrading the printer, I will need to move things around. So this again allows me to configure things. So that's basically it. But it combines a lot.
Thanks. I like it. Next up, we have Kevin T. with a power scraper.
Hello. I am redoing a lathe from 1935, which is a whole project in of itself. But one of the things that you need to do with metal surfaces is to make them so that they're both very flat and they slide evenly. So let me show an example of this. If you look on this part, you'll see that there are some parts that have blue. That's kind of glaring out. On the panel lamp. Well, okay, it's fine. Now what have I done? What did you do? I pushed too many buttons.
Just turn it
Hang
off
on, I think it's coming up.
There we go. There you go.
Okay. So like on this surface here, there are parts that have pigment and some that don't. And the way you do this is you take a surface plate, which is a precision ground flat surface, and you put ink on it, and then you put this piece of metal down, and you can see what parts are touching and what parts are not. Now if you can see, there's some lines there, and that's kind of where I've already started working on it. But it's not touching all over. So the point is that then you come and you find all of those places that are high, and you scrape them off. And then you repeat that over ad nauseum for hours and hours. It's lots of fun, let me tell you. So here, actually, I've gone and I've done it, and I don't know if you can see there's a lot more places that are touching now. So that's going to have a lot more contact, and it's going to be a lot better surface. And you want a little bit of that mottled appearance, because you don't want it to touch everywhere. Those places, you want it to be broken up about 20, I think about 20 points per inch is ideal, and then that can hold metal. So that's the reason why you would have a scraper. Unfortunately, the best scrapers, there's like a brand called Biax, and they're like $3,000-$4,000. They're really expensive. And so because I didn't have that or want to spend that much money, I decided I would make one. So I took a Sawzall, and I took it apart and essentially changed where it connected to a blade to connect to this, this piece of metal here. And then there's a piece of carbide that you put in here and screw down to scrape with. A regular Sawzall has a regular stroke length, which is longer than you need. You might have a stroke length that you really only want it to be about this much. So then that comes into the issue about how to change your stroke length. So a standard Biax, I think there's actually different kinds. They use this mechanism, which I've seen on the internet described as a wobble mechanism. Your motor hooks to here, and then inside here there's a ball, and this is the shaft for the ball, and so it can rotate like this. And it does that based on how you screw this. And as this thing turns around, it kind of is a very interesting mechanism, and it goes back and forth to do that. And so it's infinitely variable depending on how you change the angle and how angled that is. Now some of these Sawzalls will have that angle built in. They just have a bent piece of metal. It's not variable, but that's how they generate the reciprocating motion. But the way that I needed to have this work is I needed to have something called a Scotch Yoke. So on this is a parts list. I don't know, I guess that's not in focus very well. The motor comes back here and it spins around, and it spins this wheel, and this wheel has a little peg on it. And as that peg goes back and forth, this part up here is called the Scotch Yoke. It's like a line, and it's got a ridge. So as that pin spins round and round, that piece is going to go forwards and backwards. And the radius is how far that pin is out from the axis of this part depends on your stroke length. So to modify this, I had to take that wheel and had to remachine it so that I could then adjust the radius of how far that pin is. So I basically have it working, but I would like to ask a call out if there's anyone that knows a little bit more about electricity than I do. It's got a variable speed wheel here, and it's got variable with this. And so you kind of have to push it halfway in, because if you push it all the way in, even with this down at 0, it goes too fast. So what I would like to do is to be able to push all this way in and lock it, and then have this dial be able to take it all the way down to a slow speed. So I think this is just a potentiometer. This needs maybe some higher resistance. But I don't know if there's anyone that'd be interested in helping with that. That would be appreciative. That's all.
You share a video, because that seems super awesome.
Actually, I did make a whole video about the making of it. That's on YouTube. My name is Kevin Toppenberg. If you search for that, I got a whole thing. It's too long.
I just want to see it power scraping.
Yeah, okay.
Next is Billy, who's going to come from behind the camera and show a parts washer pump in the beautiful teal.
Okay. Okay, so this project started off as, should I buy this or should I make it? The parts washer that we have back there has been around for a while. It was salvaged. It was missing the pump. I had a pump from a smaller one that I said, well, I can make it work with that. Got to looking and doing some research. To buy the replacement pump cost about the same as it cost to buy the whole parts washer from Harbor Freight, and they're out of stock. Okay, and I wasn't going to spend $127 on a whole new unit when we had one. So I decided I was going to make a housing to hold the pump and use the pump that I had. So I started off, for the record, I think I'm up to 15 distinct tools on making this project, and I'll list them off here in a minute. So the first thing I did was I laser cut out a sheet metal template, or a piece of wood, so I could use it as a template, so I can plasma cut around it for the machine, or for the box. So let's see how bad you can see me do this. No.
Take the safety course.
It's fine. I didn't get burned. So the template works really well, except for going left and right. I don't know what it was, but I could draw it toward me really steadily. But moving it back and forth was a different story. I got through that. And what I ended up doing is, after I got the pattern cut out, I went to the 2x72 belt sander and cleaned up the edges. Then I went over to the metal press brake and bent it into the box, as you can see there. All right, and then also, you'll notice these little rivet-looking spots right there. Those are spot welds, so I broke out and used the spot welder to spot weld the joints in. All right, and you can see my sheet metal work needs some improvement. I got some gaps in there, but for what this was, it doesn't need to be waterproof, so it'll be just fine. Let's see. All right, next thing I did was I took this little 2x2 tube and tack welded it on using the MIG welder. That was a frustrating exercise, as this sheet metal is very thin and I burned a hole through it at one place. So I've got a extra piece that I put on the inside and spot welded back in place to cover up, to patch the hole that I made. And I think that's all I got on the phone. No, you can see the spot, the patch job right there. So, and you can see the back of it where I welded on the back plate. So, in addition to doing all that, I used the Bridgeport to mill the tube here perfectly flat. I had to drill some holes in the four corners for the switch plate and tap those, so I used the tapping arm to tap that. I had to use the drill press to drill the hole for the pass-through for the, I guess I could stick it under here too, for the cord. Oops, zoom it out. There we go. So I had to drill a hole there to pass through the cord to go through the switch box. Had to use a woodworking jigsaw to cut the hole for the switch and use some files to clean it up. And let me tell you, that was an exercise that I don't want to repeat. We need some better tools for doing inside cuts like that. The Bridgeport can't mill perfectly square holes because it uses a round tool. So you have to use something like a jigsaw or a bunch of file work to get it to be perfectly square. So that was kind of fun. Let me bring up the list of my rest of the tooling that I used. So, there we go. Oh yes, I used the lathe also. I had to bore out and tap a pipe thread for the fittings there. The tapping arm, hand taps, jigsaw files, and the lathe. So yeah, I used quite a few tools to do this project. I couldn't have done this in my garage or in my little workshop at the house. So, testament to what you all can make here. I probably spent way too much time, but I saved myself $120-some by building the pump for our parts washer and getting it up and working. That's my show and share.
Very nice. And that'll be in the the machining shop? Yes. Next up we have Mel, who is showing block print exchange? I don't know.
Hello. If you haven't met me yet already, I'm Mel. I'm somewhat new here.
Hi, Mel.
Hello. Lamp, I'm assuming. There we go. Great. Oh, there's water here. That's not good for prints.
Sorry about that.
That's fine. There's a dry section right here. I think I can maybe use. I can hold it above the water too. That works as well. Are you sure? Okay. Thank you so much.
I did some testing with it earlier.
But no demonstration.
Thanks, Billy.
Thank you so much.
Follow Billy into the swap center
Thanks.
afterward for a demonstration.
All right, it's fine. So I've been making block prints. I've started a project basically for the past year where I make approximately one block print every month. And if you don't quite know what I mean when I say block print, it's essentially just carving into rubber to make a stamp and then using that to make prints. So these ones are not done yet. And as much as I kind of wanted to hold off and wait until they were done, I did want to propose a sort of print exchange because this originally had started as, I can zoom out, right? Yeah. Perhaps. Here we go. This originally started as a way for me to kind of stay in touch with people and write people letters, and then it kind of morphed into this like print exchange with my coworkers over the past couple of months. So if anybody's interested, I'd love to trade some things for these. They do not strictly have to be prints, like it doesn't have to be print for print. Really the only rule I've had in the past is it has to be something that you made, and I'm pretty open to what that can be. So if anybody's interested, I don't have any, as I said, these aren't done, but in the future, near future hopefully, would love to exchange some prints for miscellaneous objects.
What kind of ink do you use?
This is just block printing ink. It's like a specific ink from Speedball. So
Nice.
thank you guys.
I think we should do more art trading here. I think that'd be super fun. Next up, we have Sabine with the fridge magnets.
All right, hello everyone. As it turns out, my Knox Makers membership just ends up being a $50 a month pass to use the laser cutter because that's all I do at this point. So this is, I know, right? So this is, so this is just an idea that I had because I was having a very stressful time at work, and so put that together, and it has a magnetic piece of magnetic tape attached to it, and I liked it so much that I made a whole stack that I'm gonna go send to my friends. It's like several. I'm probably gonna make more. This one, these turned out a little darker because I think I put the laser's head a little higher, or the bed was too low or something, so it didn't turn out quite as clean as this one. But yeah, I guess there's no precise way to set the laser distance that I know of. But yeah, that's pretty much it. And to Mel, I would like to exchange one of these with you. And yeah, that's it. Thank you.
I think $50 to use a laser constantly is a good deal, in my opinion. And the last up we have Sean, who has the reader's best friend, but he was carrying a bucket before, so I don't really know.
It was just to throw you off the scent. One of my New Year's resolutions is just to read more, and usually that means I'm carrying around a paperback book a lot. And if you are an avid paperback reader, you know that sometimes, or all the time, they just do not want to lay flat at all. And they have the spring tension strength of a bear trap sometimes, and it's really hard to hold them open. And I have a habit of walking and reading and having to keep one thumb jammed in the book to try to read with one hand while I'm blindly feeling out in front of me. And so I start, and after a while, this really starts to, you're gripping and holding this thing, so your hand starts to get tired, it's pinching your thumb, everything starts to hurt. So I was looking for solutions on how you can hold a book one-handedly, and I was looking online, and there's various solutions made of silicone and wood and metal, and like all of them cost at least $10. Even though like the ones made out of wood were like $14, $15. And so I said, hey, that shape looks easy enough to duplicate. And so one Tuesday I made this for the low price of $0.0 and just found some scrap wood, drilled a hole in the center about big enough for my thumb, and did the rough diamond shape. It has some stuff from the previous user, and then just cut it down on the bandsaw and tried doing some things where, because some of the ones I saw had nice little curves to it, so it fit right into the curve of the book pages. I was trying to do that, but I just decided it really wasn't worth it. Also, I hadn't tested it at that point, so I said, let's see if I actually need it. And so I've been using this for a couple weeks now, and it is like my best friend. And I can just fit it in my pocket and carry this around with barely any force on this. I can just lay my thumb across it and just keep it open. And the only time I ever have to, and then I could also use my hands pretty much with this on because it's lightweight enough to not interfere. And so as soon as you get to the bottom of the page, then it's just back up to the top, and there you go. So yeah, it just helps. I think next I just have to make a book glove that just will strap the book to my hand, and I can just walk around with it all day. So yeah, this is. Yeah, exactly. Yeah, I can. I think the only thing I might do differently with this, I was thinking of maybe doing a laser cut version out of clear acrylic, so I don't even have to move my thumb to read the rest of the book pages. while I have it there, but we'll see. That might be too much to look through anyways. So yeah, just a neat little thing for the low, low price of free.
My mom actually asked me to make her one of those, and now you've reminded her on camera that I said I would do that. So I haven't forgotten, I promise. Maybe. That ends our show and share. Does anyone else have something that didn't get on the list? No? All right, so announcements. Last week was our annual meeting. I don't know if the recording still exists. It probably still does if you would like to watch it. We voted electronically, similar to last year. If you haven't seen the email, the entire board got re-voted on, so thank you. And the Western Heights project, we are still going to pursue that. So if anyone has any questions about that, you can find a board member or post on Mattermost, and we will fill you in on what you missed. Currently on the calendar, there is an oscilloscope class, but it's sold out. Although it's virtual, so I don't know if you asked Ray really nicely, he might let you still come. And then there's also a laser authorization class where you can make cool fringe magnets and 3D printer enclosures and other cool things, templates, all kinds of things with the laser. That is almost sold out, so buy your tickets fast if you want them. And if it is sold out at this moment and you ask me nicely, I might let you come anyway. The bins. Now it says bins here. So if you were at the annual meeting, we've been talking as a board. As you can see, we're moving around. We're moving into the first bay. We're going to be moving some of the member storage in the wood shop. We're going to be adding more storage in the second bay. Lots of moving. Lots of stuff. There's lots of stuff laying around. And in an effort to constantly improve organization and keep this stuff contained so it's not like falling on our heads or poking us in the eyeball or tripping us, we have a new rule that everyone has to keep their member storage in a bin. So we will be enforcing that soon, probably in the next couple weeks. If you need a bin, we have some for sale. These are more sturdy. They are $30. If you'd like to buy one, you can talk to one of us afterward. We have some less sturdy ones if you don't have like 50 pounds of wood scraps that you need to store. You just need to store some light things. We have some less sturdy ones coming that you can use as well. Or you can go to the store and buy your bin yourself. But if you're lazy like me, you can just buy it right now. But anyway, if you have a member storage space, you need to put your stuff in a bin. It needs to be all in the bin and not like overflowing all over the place. And it needs to have your name on it. Because if we move the shelves and then we pick it up and move it, who does this belong to? And you don't want it to end up on the hack rack if it's something you care about. If it's something you don't care about, take it to the hack rack yourself. Does anyone have any questions about bins? Yes.
Is there a space, a size specification for the bin?
About that.
They're 18 by 24.
18 by 24. Thank you for giving actual numbers.
Full name, please.
Sorry?
Full name, please.
Full name, first and last name. Even if you think you don't have two of you here, there probably is. What did you ask?
Does the lid have to close?
The lid does have to close. I've seen your storage space, Arno. The lid has to close. We don't want stuff falling all over the place. That is the point. Yes?
How do we get a place to put our bin?
You can find one that's empty that has no name on it and put your name on it and put your bin with your full name on the bin in that space. And I'm going after this to clean out some spots that I've noticed are empty. So, everyone, yes? You can make your bin out of wood. You can talk to Brian. He has a very nice tool box. And the person next to you, who I don't know, also has a very nice toolbox.
Yeah, also me. Thank you, though.
Okay. So you have two spaces. Is that what you're telling me? Don't tell me that.
Better to ask forgiveness.
You may make your bin, but we were actually discussing this because Brian's bin does not look like it's gonna fall. Stuff is gonna fall out. But there are other bins that even have tops that looks like stuff is going to fall out. So if your stuff is nicely enclosed like Brian, then you can make your own bin and it doesn't have to have a top. But the point is we want to be able to pick it up, put it on the ground, move the shelves, put it back on the shelf without getting tetanus or something falling in our eyeball. Any other questions? That's all I got for tonight. Go make cool things and put your stuff in bins.